Hey everyone, welcome to another Make It Better. Before we introduce our next guest, I want to do a little bit of an explanation of how we got here and who this person is, because they do some of the most cool, crazy, wild things that I've seen in a long time, and they're unique ways to use SolidWorks to be able to do that. So about a few weeks ago, we were at SEMA. SolidWorks had a booth at SEMA. We were there meeting with customers, and there was these really cool designed components out there, mini monster truck, and this amazing gooseneck trailer was out there. And we were lucky enough to run into Joel, who's our guest today. And he's been gracious enough to jump on with us in his busy schedule. So I would like to welcome Joel from Overkill Racing and Chassis. Joel, welcome aboard, man.
Hi, how's it going? Thanks for the humble introduction. I appreciate it.
So who are you and what is an Overkill Racing and Chassis?
Well, that's a good question. So I'm Joel, and I'm the owner of Overkill Racing and Chassis. And getting right into it, I guess what an Overkill chassis would be would essentially just be, in most cases, a mini monster truck is kind of what our bread and butter is. We build these really cool tube chassis monster trucks. We also build these crazy tube chassis trailers, and everything's driven through SolidWorks. But I guess in terms of what an Overkill Racing and Chassis is, anything that see, there you go. Look how awesome that thing is. Anything that is on four wheels and tires and has a lot of horsepower, we're totally going to be interested in it, and we're going to want to try and build it. So awesome. I
mean, the picture speaks for itself. We could just end the conversation because it's pretty hard to beat that image of a mini monster truck jumping, right? How did you get started? Like there's always these questions, right? People that do really cool, amazing things and push the boundaries of design and manufacturing. I'm always curious myself, like, how did you get started? How did you get into this realm or arena?
Oh my gosh. So that's a really, really long question. Or has a long answer to it. So I'm going to give you the Reader's Digest version. So long story short, I went to college down in southern New Mexico State University, and I was getting my degree in biology, and I initially wanted to try and go be an orthopedic. That was what my plan was. So I went through, I got my degree in biology, and then I ended up getting, a handful more degree stuff, and I ended up getting into a PhD program in cellular molecular biochemistry. And while I was in my PhD program, I decided I wanted to build a little, I guess not little, it's a 68 Chevrolet Suburban that I want to put on 54-inch tall tires, and I wanted to build it in my two-car garage. And so primarily me by myself starting out, started building this Suburban, and eventually some of my good friends started getting involved in it, and we ended up bringing it to the SEMA show in 2011. And once it kind of went to the show, we started walking around, we saw everything that was there, and we were like, man, we could totally do this. We think that, we definitely got a chance to build some neat stuff. And so in 2012, the next year, I had an individual, Todd Weston, who owns the Kid KJ mini monster trucks. He called me and said, hey, I need you to build this mini monster truck. I had no idea what a mini monster truck was at the time, but I knew that I loved monster trucks, and I knew that I had an attitude that, I was willing to say yes and figure out the details later. And so I started building this mini monster truck for him, and it ended up doing really, really well at the 2012 SEMA show. And it gathered a lot of attention. And I think part of it's because it was driven by, at the time, a 7-year-old kid, and it had a 468 cubic inch supercharged big block, about 700 horsepower. And what is cooler than knowing something like that is being driven by a kid? And so the next year, we ended up building another mini monster truck, and the following, years past that, we started getting a little bit more traction. We ended up building a really cool 1964 C10 that was fully laid out, had a 588 cubic inch big block, full tube chassis, and that was in the McGuire's Car Crazy Corral, and ended up actually doing really, really well at the 2014 SEMA show. Oh my gosh, seems like just yesterday. And, things just kind of started getting some momentum. So after SEMA 2014, I, kind of was at a crossroads. I was doing my my education stuff, and I was teaching introductory biology 111 to incoming college students, as well as, going to school for grad school at that point. And at night I was coming home and, building these monster trucks. Well, I talked with my wife, and Colleen was like, hey, you got to pick one or the other. You can't, just continue, doing both these things at the same time. You're burning the candle at both ends. And I told her I wanted to do the monster truck stuff. Unbeknownst to me, I think she probably hoped that I was going to choose the the orthopedic side of it. And instead, I, kind of dove elbows deep into the mini monster truck stuff and into what is now Overkill Racing and Chassis. And I hate to say the rest is history. In 2016, we got the opportunity to come up to Salt Lake City, Utah, to help on the Diesel Brothers TV show. And when we did that, that really kind of changed the trajectory of the company, because for the next 63 episodes or something like that, we focused mainly working exclusively with Dave Sparks and Dave Kiley, Diesel Dave, and Heavy D, building whatever rad junk we wanted to build on the show. So that's what actually brought us up to Salt Lake, and we've been up here since 2017. And that's kind of where we're at now.
So there's a lot to unpack in your history there. One is, I think you made the right choice, by the way. Being a car person myself, you're doing amazing things. So you gave a 7-year-old a mini monster truck with a 468 cubic inch supercharged big block to drive.
Awesome parents.
Amazing parents. Amazing parents. And then along the way, you got to the point of you connected with Heavy D and those guys to be able to build all this other cool stuff. And then that sort of led to your refinement of designs. The one thing I will say is you're creating lots of buzz in the chat, which is great. And there is a question for you, because I do want to remind everyone this is live. So the question is, have you ever brought your mini monster trucks to a county fair?
We have. So not me specifically. So we mainly just build them, which kind of sucks being a builder, because when you build something for someone, it's like right when it gets cool is when it leaves. Once it's done and once it's time to like start driving and enjoying it, that's when they end up, going off to the owners. And so we have had a lot of them go to a lot of the county fairs, and there's probably a 9.9 out of 10 chance that if you've gone to any of these, monster truck shows and you see one of those little mini monster trucks, there's a good chance that it was probably built by us.
Okay. So the car nerd in me, are all of the mini monster trucks big block?
No. If it were up to me, they all would be, because there's no replacement for displacement. But we have
exactly.
It's crazy to actually look back and think we've built them with just about every conceivable motor you can think of. The smaller ones that, we kind of have these half scale ones, which is kind of like the Old Glory, that American flag one. We consider that a half scale monster truck. And by half scale, it's a 42 inch tall tire. It's a 108 inch wheelbase. Those are typically running either a supercharged LS or that one has a 632 cubic inch big block. The third scale ones are a little bit smaller. Those actually run like a K series Honda, or like a Honda 2.0 with a transaxle. And we actually mount the mount the motor sideways. So essentially the transaxles are the front and rear, basically going to the front and rear axles. Okay. So, the one motor that I really want to build a mini monster truck with would be like a 2JZ. I think that'd be so cool. I don't know, obviously, like the problem is that a monster truck is cool because of that instantaneous throttle response, that power right off idle. And you're just not going to get that with, a 2J. Obviously, you got to build boost and build power that way. So that would be the only caveat, but it would sound super rad if it was bouncing off the rev limiter and
you can't. That sound would be a unique sound as much as a big block. screaming around the track. That would be pretty wild.
Yeah, it'd be so awesome.
There is a question in here, and I know we're going to get to this a little bit later, but I'm going to ask it now, and then we'll explain a little bit longer. But the question is, if I wanted to get into welding and fabrication, where do you recommend I start?
Really good question. So most, in high school, we didn't necessarily have We had like wood shop class. We didn't have anything for welding, fabricating. I know there's a lot of high schools that do have that. There's also a lot of community colleges that, offer some courses to help with, kind of getting into that. There's also a lot of trade schools that help with that. If you're specifically, it depends on if you're looking to try and get into motorsports fabrication. If you're looking to just get into pipe welding, stuff like that. Scott Robbie with Precision Welding Academy down in Texas, he's really big in the pipe welding side of it. And if you're looking to get into automotive fabrication, there's a fab school. There's a couple of them that help on that front. Or if you don't have the ability to just uproot and leave, there's probably a local community college that's going to have some welding and potentially some fabrication courses that, would be available. For me specifically, when I was down in Las Cruces, New Mexico, Doña County Community College was really big. And I got to give a quick shout out to my homie, Pep Gomez. He's actually my only welding instructor I've ever had. Whenever I was just starting out, he helped me out tremendously. And, it's kind of neat because, when you're practicing, welding and fabricating, if you're not using, the proper techniques, it's like practice makes perfect, but it's like, yeah, but if you're not using, the right settings or anything like that, then you're not going to get any better. You're going to get a lot of hood time, but it's not going to be beneficial. So that's where having a nice foundation and learning from somebody who obviously knows what they're doing is really going to help.
Yeah. I mean, I couldn't agree with that more. Like how I started out, having a good mentor that can teach and educate as much as just change this and this and this and make it work. Like, to me, the understanding the fundamentals of anything is the most important out there, right? And some of us are lucky enough to have those. Sounds like you were, which led to this. We will get into showing some SolidWorks here and some designs here in a little bit. Let me ask this question, and I think it's going to lead to maybe showing a little bit of the screen here, if you're cool with that, Joel. The question is, do you model the chassis using SolidWorks weldments? How do you break out the tubes for proper cut sizing and coping?
Oh my gosh, now we're getting into the meat potatoes. This is what I was hoping for. Yes, we do. So I design everything 100% in SolidWorks. If you're just doing tube work, there's some other softwares that work really well. I think Bentech's a good one if you were just doing that. But the problem is that Bentech doesn't really have any sheet metal functionality, and so, or anything that's efficient. And so for us, it was easier for me to just transition 100% over to using SolidWorks so that when I'm designing an entire assembly, I can, use one software the entire way through. And so when it comes to actually designing a lot of the chassis work, I'll initially start out as like a 3D sketch. And then once I kind of have my my rough design, I'll actually use weldments and go through and determine different kind of like a hierarchy. Like for a chassis, you've got your frame rails, you got your roll cage, you've got some of your other pillars and so on and so forth. What I like to do is I like to just kind of focus in one domain or one constraint and then move from there. And then once I have my entire weldment designed, then I'll actually go through and save those bodies out individually. And then that's where I'll go through and do some of my tube normalization and my etching. And if you want, I mean, I can bust out my my model so that you can kind of see what I'm talking about. Oh my gosh.
Well, before we jump into that, the one thing I do want to preface with this, though, is Joel is pushing the boundaries of all types of design and manufacturing capability. And if you want to see some of the amazing things he does, you can go to his Instagram, Overkill Racing Chassis, and you can see some of the things he does. Because as amazing as this trailer is that I've seen in person, and I'm still figuring out how to win the lottery to buy one, the way that he approaches weldments and sheet metal and using the manufacturing tools to actually make these is what separates everything he does from everyone else. So go ahead, Joel. I had to preface that because you're pushing the boundaries on so many things for design to make it manufacturable.
Oh man, that means so much. So as you can see here, this is the main part of just the this trailer, and this is a trailer that we had brought to the SEMA show earlier this year. And so what I have here is I have a couple of things. So when I talked about making a sketch first, so I knew real quick, I have a mini monster truck here. And so I have the wheelbase and everything on the monster truck. So I know what my design constraints need to be sat within. And let's see, I've got some big chunky files open, so we'll see how it plays. So when I initially started out this trailer, I knew that I had a set wheelbase that I wanted my trailer to sit at. I had an overall length that I knew that the trailer needed to be at based on what the wheelbase of the mini monster truck is, which is what this guy is. I also had a breakover point for where the dove height needed to be. And so I wanted to make it to where when the monster truck, say the owner blows out a shock and, the truck literally needs to get wenched back on the trailer. I wanted to know what my cradle height was when it's fully bottomed out to make sure that it breaks over this cam over point of the dove when the tires actually started to contact going up the trailer. And so I also wanted to make it to where the tires, when it's on the actual trailer, sit tangent against both of the ramps of the or both the humps of the trailer itself. And the last thing I wanted to do was we had to make the trailer look rad. We had to lay it out. And so as much as I could. So I made it to where the tires actually tuck all the way inside of the frame rails. So that, when the trailer, which is on air ride, is laid out, it literally looks like it's tucking those tires. So you got to have a little bit of style points through there. But then on the front side of the neck, I just measured out my Big Tex gooseneck trailer and essentially just stole some of the dimensions of what I needed there. And then on the receiver ball height, I knew that this trailer was going on a custom built truck that we were also doing some stuff on. So the ball height is actually a little bit higher than on a normal truck. And I made that so that when it's fully laid out, it all kind of like seamlessly looks a specific way based on what the trailer was gonna, or based on what the customer wanted to look like. So I don't have the dove in this model because this is just the trailer frame. So essentially what I'll do is I'll do my sketch and then I'll establish the ground. So I know where my ground height needs to be. And then like I was talking about earlier, I'll actually start doing the frame rails first. And so I have some subfolders here. So this model is, this one particularly is 1100 sketches. So anyone who's done any CAD design stuff knows that it may not look like it's a very chunky assembly, or part file, but each one of these has some chronological frame or folders in it, which make it really, really complex. But yeah, so essentially once I have my rail design established, I'll go through and I'll do my driver rail, my passenger rail, and then I'll go through and kind of systematically lay out the design of the base of it. And then I'll go through and I'll start doing the neck, doing the cross member, so on and so forth. And then once I have this design, which I consider my trailer frame, I'll then go into this is my assembled trailer. So this is kind of like, this is a dynamic assembly. So this actually has all of my suspension components, which all move and cycle. And let's see if it'll play nice. I even made the airbags to where they'll rebuild and, typical SolidWorks. I have the bags to where they design up against, or they're mated against this face, and so when they rebuild, they expand. But I've got so many big files open that my graphics card is probably just
and I think that's one of the things to clarify is you have the whole scanned body for the mini monster truck over.
Which is a huge file. So it's I'm asking a lot of a laptop right now, which that's the other thing is I'm doing this on a laptop. But anyways.
But I think the one thing that's interesting to point out here is the way that you have like the frame rails and the weldments and you have it folder set up in your folders is a little bit more of probably how you're going to build it, right? You're going to build each side of the frame rail, then you're going to build the sections together.
Yeah. So that's exactly how I'll do it. So I'll know based on how this is designed, I'll go through and I'll have different fixture assemblies for how I need to lay everything out. And yeah, that's all based on my my design tree in terms of where a lot of the components are going to go. And so once I kind of have the tube work finished out, I'll then start doing some of the sheet metal work. And this trailer was kind of tricky because, you know, I initially had the idea of wanting to make all the sheet metal components. Let's see if we can make this shaded. This is, again, I have it in large assembly settings, but this is a really, really big file. So yeah, so I wanted to make it to where the top surface of this sheet metal was on the tangent of the tube, which looks really cool. Now it's all said and done in terms of everything's like seamless, but it was a bear getting all these tubes welded out. And so Rod, my main guy, he actually had the honor of going through and blend grinding all of this stuff, which was absolutely brutal. So the final product, if you got a chance to see it, is really neat, but holy guacamole, it was a lot of work. But yeah, so I know getting a little sideways there. What I did,
not to interrupt too, but I think some of the things on the trailer that, you know, you and I were talking about at SEMA was your trailer is adjustable in height on the rear axle, which is non-typical, right? I have a big Tex trailer too, so I can appreciate the pulling the dimensions from that, by the way. It makes life easier. But then you have a special locking mechanism on the back. So you're using air and hydraulics on this trailer, which is a little bit unique. So can you talk a little bit about your design of how you're coming up with these ideas and integrating the systems? Because it is weldment and sheet metal, but there is a ton of engineering that you have into this to make this truly unique.
Yeah, it's a really good question. And actually, I wanted to show this tube really quick before I forget. Once I actually have my weldments laid out, I save all the parts out as a multi-body part, and then I go through, and that's where actually I'll do all my tube normalization and my cut profiles. And let's see. So just because someone was asking this, essentially, I'm actually going to be starting to hopefully try and work with SolidWorks a little bit to help on making an efficiency on the tube normalization on the cut profile side of things. And unfortunately, it just doesn't work very efficiently right now. So what I want to try and do, hold on. Hi, can I help you?
Yeah, I'm wondering about that Land Rover that's parked out there. Is it yours?
Yeah, I'm on a call right now. Is there a way that we can chat a little bit later?
I can come over, but I do need it moved.
Oh, okay, perfect. All right, thank you so much.
Yeah.
Sorry about that.
Hey, work never stops, man. The one thing I will say about the tube normalization and what you're talking about here, this is 100% for the manufacturability of how you're going to cut it, right?
Yeah, exactly.
You have a tube laser, correct?
Yeah.
Okay, so I just wanted to clarify that for some people that may be wondering, like, okay, well, he created all the weldments and the copes are there. The point of the process you're going through is to make this so I can program it on a tube laser, cut out all these pieces, and add fit functionality to make it manufacturable.
Yeah. So essentially all we're doing is just a bunch of ruled surfaces, do a surface trim. And then once I have all my surfaces normalized off the axis of the tube, which is the center line of the tube, then I'll go through and I'll delete all those outside surface bodies, and then I'll just thicken it to whatever the material thickness is. And then I'll do a wrap feature, and I'll wrap whatever my part identification is. So I know DD1, that's driver diagonal 1. And so whenever I go back to my my model, let's see if she'll play nicely. I then have this thing all laid out. And so what I did was I made it to where, like, driver diagonal 1, driver diagonal 2, driver diagonal 3, 4, 5. I made them to where they're all horizontal or parallel with the ground, and they're all on the centerline portion of the tube. So aesthetically, it looks kind of neat, but then it also makes it easy from a functionality and manufacturing standpoint. When Rod puts this chassis together, he knows that he just systematically needs to, follow down the line, and all the tubes fit in there nicely.
Yeah.
So, but yeah, I hopefully that answered that question. And then going on to the the cantilever cam design. This was a pain in the butt, to be totally honest. It was just a lot of moving components. And really what my focus was I wanted to make sure that when the trailer was at full bump, when the trailer's at full bump, which right now this is static ride height. The links are parallel with the ground. When the trailer's at full bump, this face here is parallel with the ground. So whenever you drop the dove down, it essentially sits, nicely on the asphalt. If in a perfect world, you're on a perfectly flat surface, which clearly is never the case. But to do a lot of that, I did a lot of 3D sketching, and then I did a lot of essentially just like dynamic sketches without modeling a single part. And I think that worked out really well because it allowed me to design this cam to where it moves fluidly, but also the hydraulic cylinder is always moving in the same direction. So it's still continuing to move forward, even though the dove starts to drop down. And it gives an auto locking design with a check valve on the cylinder. So there's no way that when the cylinder is extended, that we'll have any sort of hydraulic fluid. If we lost hydraulic pressure, we don't have to worry about the dove essentially coming back over and dropping down on itself. So, and then in terms of just, making a mount inside of there, I did some, capturing pins that, have a bunch of little machine parts that kind of hold it all into place. And then, what's neat about having dynamic assemblies is the ability to, kind of sneak your eyeballs in those windows and make sure that everything clears correctly and how it needs to. It's kind of hard to see that. I could hide the chassis if I needed to, but it's always neat being able to, utilize a software like SolidWorks to do neat ideas like this, because if you were to try and do it on your own, I mean, there's just no way that you'd be able to kind of conceptually, kind of come up with, ideas like that. And then to proof them out, it'd just be very, very difficult. The one caveat I was going to say with something like SolidWorks or any CAD design software for that matter, is that here's a good example of an idea that I had. I wanted to try and make the top of the trailer with polycarbonate so that you could see through it. So, you kind of see all the neat, sheet metal work underneath on this trailer. And what I didn't account for is the fact that, in a model, it's very easy to pan this. It's easy to like move it around. But this vantage point is like 20 feet off the ground. So, as a person, you really only see it from like right here. So that's kind of where you can kind of get, can't see the forest of the trees is whenever you do unique design features like this, you can't necessarily appreciate it in reality unless you're like standing on a ladder. Then you can look down in it. But It's always funny because that's one of those things like I didn't even catch that until after it was already done, and I was like, oh well, that was kind of a waste of time. But
I don't know if it's a waste of time. It's a learning experience, right? I mean, let's be real. When you talk about like your cam locks and things like that, you think of way back before 3D models, like the way that people would have done that is prototype after prototype after prototype, torches and hammers and everything else. And now you have the ability to prove all this stuff out and then make it in hopefully one revision, maybe two, and be like, yep, that's what I want. And I think that's really the power of being able to visualize and use things like dynamic mates and motion and that stuff. Yeah,
I kind of lucked out, to be totally transparent. That was a single revision, or not a single revision. We bolted that sucker up and cycled the suspension. It worked really well. The only thing that you can't account for, and anybody who's modeled anything in SolidWorks, whenever you start to get multiple dynamic mates, is getting them to all jive nicely is like a perfect scenario. Like normally it's going to flip over or it's going to kind of just go crazy. It works really well. But when it hits this breakover point, when this pivot point, and this pivot point are all in line, it makes like a slight popping noise. And literally all that is that it's just where it's kind of having that, like, it's almost like a dislocation. It's just like it breaks over that point and the trailer makes like a slight pop. The only thing that I was thinking that I could probably do to eliminate that if I were to do one of these again in the future is if I ran this cantilever and this cantilever in the middle here, so they were tied together. So they were on like a fixed plane, always cycling. Because this one and this one, even though there's some check valves, some other things that we put in there to make sure that the fluid is traveling equally through both cylinders, there's no way to really know if it's the exact pressure on both of them. And so I did want to try and put the cylinders on outboard of where the tires were going to sit, just so that it had like maximum load efficiency and it didn't potentially bend the tube if the monster truck was wadded up whenever it had to go up on it. But for all intents and purposes, it works really, really well, and it's definitely a neat focal point for sure on the trailer.
Yeah, it's really cool and amazing. It's funny you mentioned the kinematic joint thing. I have a random old Pony Express story from way back in the late 1900s. But when I went from 2D to 3D, one of the things that I was tasked with was doing some mechanism improvements on some dump gates that went on portable concrete plants. And so we had them, and they would do like that pop, sort of like what you're talking about, but it was all mechanic with one air cylinder in the middle, right? And so what we did is we went through in 3D CAD for the very first time, and we did the motion pieces like what you have. And it was funny how when you get everything just right, the simulation in the CAD model would work smoothly. And if anything was just out of position a little bit, it would do that snapping. And so we just kept messing with the links until we got the smoothest motion. And we went out and put the prototypes together. It was like not that much different, but just changing those links a little bit made all the difference in how that mechanism moved with the air cylinder. So yeah, it's pretty amazing how you can fine tune that stuff into a design model these days.
Yeah, it's so funny you mentioned that, because I modeled the threads into it, and I just used the thread feature in SolidWorks, but this hydraulic cylinder has Acme threads on it for one reason or another. And so one rotation of this this little clamshell thing in the actual cylinder is like a 1/4 inch, not quite a 1/4 inch, but it's a drastic change. So there's if these were like a fine thread, I bet you're probably right. We probably could like adjust those things out and get them to where it plays nicely. But yeah, that was definitely kind of a pain in the butt. But yeah, dude, I bet you that was a really good feeling, being able to get it to where it worked out obviously smoothly.
It was a surprising moment, because I'm like, well, I think this is right, but you go put it together, and it was like, oh wow, I look like a rock star today. That's great. We did have one question come in, and the question is, on monster truck chassis, what type of G loads do you assume during structural analysis?
So another really good question. I know that SolidWorks has the ability to do some FEA stuff. So we're running SolidWorks Professional. We're on SolidWorks Premium. And I know that you can do some load analysis. I'm too stupid to know how to do any of that stuff, and I haven't watched enough YouTube videos to know how to. But I've got some really smart friends that are really good at that, and I don't know if they have a different version of SolidWorks or if they're using a third-party software to do finite element structural analysis test ratings on it. But I just send them the model, and they'll take a peek at it. The only caveat is that they essentially, what they've told me is that like for instance on this mini monster truck, is that they say a lot of the information is kind of anecdotal. It's based on user inputted data, and so you kind of have to say with I guess like some confidence what like your actual weights are, and what your simulation, if it's going to hit this corner at 66 miles an hour, like where's that load gonna transfer through. So essentially all we've really done is send the files off, and then they'll usually tell us like not a go, no go, but yeah, this looks pretty good from like an aesthetic standpoint. They will say that, there's certain designs where you're going to want some sort of a crumple zone, or you're going to want some, weakest link point. And, for us, we got a company called Overkill Racing and Chassis. And so if I can build it at 3/16 or I can build it at 1/4, then I'm going to build it at 5/16. Yeah, so it's certainly something we're mindful of, but it's also one of those that we're not trying to save a bunch of weight, which actually brings up the example of like this 8-to-1 exhaust that I designed. We got a lot of people that hated on the fact that it's not a sequential firing order, which I know it's not. But I didn't make it a sequential firing order because I wanted it to look rad. And I thought that it looked a lot cooler with it uniform like this. But I did make all the tubes to where they're equal length. And the way that I did that was I ran sensors. So in SolidWorks, and a lot of people don't, utilize these guys too much. Let me see if this thing will open up. I don't know why it's mad. This always gives me anxiety. Like anytime a model works great and then like randomly it'll have some reference that it loses, and just gives me anxiety. But anyways, essentially what I did was I went through and whenever I built these headers, I used the sensor feature in SolidWorks, and that allows you to, in a 3D sketch, drive a certain dimension. And so what I knew was I knew which tube was going to be the longest, which I think was cylinder bank 7. Well, I guess at that rate, that would be a cylinder 1 because the engine's backwards.
Well, it's 7, isn't it? Is it just
No, you're right. Yeah, now I'm getting confused. So
Yeah.
rear engine setup, yeah, exactly. So it is 7. So cylinder 7 is going to be my longest runner. And so once I essentially just made that tube, again, this is what's neat about having a fully modeled design and having, everything where you kind of spend that time doing that. I made it to where it's kind of hard to see. I'm sorry about that. Route around this tube. So I wanted to make sure that I cleared this tube. Then I had a jog coming back into the 8-to-1. And so once I kind of had this constraint driven, then I basically just built the other tubes to match what that sensor dimension was, but then also aesthetically try and match the same angles as much as possible. And it ended up being that this top tube was actually a total pain in the butt because I couldn't match what this design was because it has to go over the top of this tube. Whereas these ones are kind of climbing up the circle. This one's going over the top. So I had to actually come from the back side and clear it, and getting it to clear everything. You can see it was a total pain in the butt, but it was neat to see, kind of conception and reality where, you spend so much time doing some of that stuff. And then, little things like, doing some slot and tab geometry on all the miter cuts. And then I, went through and did part IDs on all of them. So I knew which tubes went where. And when all that stuff kind of goes together and snaps together in a single shot, it's definitely a neat feeling for sure.
Well, and I think that's something like, can you zoom in on that elbow there a little bit? And these are some of the things when you go to their social media, you'll see that they're doing. And this is the advancement of designing for manufacturing, right? Laser cutting, tube cutting, whatever it's going to be, is they're taking the design process to the extreme to where all these pieces sort of fit together like a Lego, if you will, and then they weld it. And I think that's what makes a lot of what you guys are doing so unique, is the fact that you're pushing that envelope.
Yeah.
The other thing is like people getting wound up about that firing order. I mean, has anybody watched the Engine Masters with Freiberger and Dulcich, where they took a hammer to all the headers and like it doesn't change the horsepower output? I mean, we're just arguing over things that don't matter when you have a big block. I mean, let's just be real here.
My man, that's what I'm talking about. That's the joke that I make, is that this is a 632 cubic inch big block, makes, they're about 1,000 horsepower. And so it's like, if I'm 1,000 horsepower, I'm 980 horsepower. It's still on a mini monster truck. So it's going to look rad and it's going to sound really rad either way. So if it was on a drag car or something where it really was important, then I'd probably be a little more mindful of that. But when people say it's an 8-to-1, or when I tell people it's an 8-to-1, they always correct me and say it's an 8-to-1 to 2 to 4-to-1. And so it's one of those that I came up with this merge collector design that kind of has like a swirled layout in it. And by doing that, I kind of wanted to proof out some of those concepts, like proofing out my 8-to-1. And then my 4-to-1, I was like, well, I can probably do it in the mini monster truck. And then, aesthetically, we can come through and do some really cool, design cues. And so, I've always had an affinity for fighter jets. So another CAD designer that I'll work with, he uses that other CAD design software that we don't talk about that starts with an F. And on his side of it, he went through and designed some of these sheet metal parts to make it to where, it has the look of a different fighter jets. So, the vertical stabilizers off like an F-35. If you look at it from the top, it's kind of the shape of like a B-2 bomber. Heat exchangers off like an F-15 fighter jet. And so the reason that I did that, oh no, don't crash on me, Solwers. This is like the worst time for you to ever crash. So the reason that we did that was, when you do look at the monster truck, it's an open profile back here. And so I wanted to have something to fill up that space. So that was the original reason we did the 8-to-1. And then going through the bumper stuff, being we don't have a tailgate, that's why I want to try and do something cool running through it.
We saw the one that was on the trailer at SEMA, and we did get a comment of saw both the truck and the trailer at SEMA. Awesome build. So kudos to you guys.
Oh, thank you.
Seeing the one that you had on the trailer that was the for sale chassis, like it's engine or not in there, it definitely looks like a work of art, and you can tell that you guys did put a lot of thought into it. So hearing you explain it, it's like, yep, I totally get it. Just looking at it, it's like that is manufacturing art. And, I think that's what makes your stuff so cool is it's not just another not just another variation of the same thing. Everything that you guys are doing and the way that you're pushing the envelope and how to design and manufacture really sets it apart. And this does lead me to a question, because I'm going to ask you a couple questions here. So where do you see the market going in terms of design and manufacturing? Because you guys are pushing the boundary. Where do you see it going?
It's a really good question. And what I'd be curious about is, so I don't use like open source or AI for anything. Not because I have any sort of paranoia. I just don't have the bandwidth to try and learn it. But Michael, what me and you talked about was, like PDF prints. I loathe making prints for guys to model or to manufacture parts, put them together, but it's incredibly valuable. It's definitely one of those that like, I know what the importance is of them. If there was a way to streamline that efficiency through the help of AI, I think that'd be awesome. I think that most print templates, the way kind of people are doing it is pretty similar. And so if you had a format that you could kind of carry some of that stuff across, I think it'd make it a lot easier on the end user or whoever's assembling the parts. Because that is definitely something that I struggle with, is that, I get so hyper focused on designing something, I forget that, sometimes it's the first time some people have seen some of the stuff that I'm going through and designing. And so for them to be able to streamline some, or for the potential of AI to like streamline some of those efficiencies, would be super rad. I have seen some of the renderings that people will send me and be like, hey, can you build this? And usually the answer is kind of, sort of. When it comes to designing from a manufacturing standpoint, let's use tube bending for an example. If you're bending something on a mandrel bender or a rotary jaw bender, you have to have a certain distance in between the tangents of the tubes. And most people don't understand that. They don't understand that, you have a set centerline radius based on what the die is, and you have to have this amount of distance, no matter what. It doesn't matter what you're doing. Even on roll bent parts, there is a straight on both ends of it, even though you have your parabolic shape through the center. And so I think that some of the AI stuff would be kind of neat to see how that would carry over. Some of the regenerative design for like machine components is like insane. It's really, really cool seeing some of the aesthetics on, what some of those parts end up looking like, knowing that they're not sacrificing any structural integrity. I think that's really cool. I think that there's going to be certain things where that human element or that human touch is still going to be incredibly valuable from a design cue and a design standpoint. And I don't know how the two will intermingle in terms of, is is something like AI going to create a lot of lazy designers and create a lot of people that, have obviously spent hours and hours and hours learning something. Now all of a sudden it's just a click of a button and there's a bunch of background information generating that. I'm not sure. It'll be interesting to see how some of that stuff lays out over time for sure.
Yeah, and we did talk about that a little bit at SEMA and with SolidWorks 26. We're adding some AI capability for automating drawings. We do have some generative design, those types of things today. But to your point, I think the big key is if you think about like the late 90s, early 2000s, people went from, you had design engineers and then you had drafters, and then parametric CAD, like SolidWorks took those two and put them together, right? And unfortunately, some people got repurposed to go do other things, but the people that were really creative and drove the bus, they just got a bigger toolkit to do really awesome things. And I think when you start looking at the AI capability is going to get rid of some of the mundane pieces and give you the ability as a creator to create new and exciting things that ultimately matter to the real world. Drawings are super important to build things, but that's for internal communication. Most of the external world doesn't ever see those drawings or prints, right? What they see is the finished good. So I totally agree with you on that. I mean, unfortunately, there are going to be some people, if they're not the creators or the designers driving that change, there might be a little bit of risk for that. But I think for people that are really pushing the envelope and want to create and build, I think it allows them to get to a final result faster.
For sure. And to your point, if it can eliminate some of the, I call it busy work, some of the filler stuff, I mean, I think that'd be awesome for sure.
Yeah. We got about 10 minutes left, and I got two more questions for you.
Hear it.
So the next one is, what is your favorite thing about design and manufacturing?
Oh man, my favorite thing is when I explain a concept or idea to a guy like, Rod or Rob, two guys that work for me. We'll try and come up with something, and I'll spit out some silly idea, and then seeing their eyes start to glaze over because they're forgetting to blink because it's just going in one ear and out the other, and being able to step back, go and model it real quick, and then show them what I was thinking. That's always a good feeling. I think that it can also get you into trouble because, you can. The better you get, the crazier, more elaborate some of your designs can get, and very quickly they can become non-manufacturable. And so being able to kind of ground yourself on some of that stuff is super important. But I really like the ability of seeing like conception of reality become something as silly as that tube chassis trailer. It was hard because I've never seen a tube chassis trailer. I'm not saying I'm by no means saying we're the first person to ever do that. I wish I knew someone else that had done it, because I would have had a bunch of questions that I would have asked them in terms of what to do and what not to do and where to be concerned from, some of the design standpoint. But I didn't have that. So I just kind of had to dive in the weeds and get really crazy on some of that stuff. But that's also what's neat, is because it does kind of push you out of your comfort zone. Because when I initially thought about, building that trailer, the end result was totally different than what I initially conceptualized in my mind. So I think that's probably my favorite thing, is just being able to come up with silly ideas and not necessarily doing it all by yourself, by no means doing it all by yourself, but being able to have a think tank and, having multiple designers, for instance, like that mini monster truck, having Austin do some of the sheet metal stuff on the bumpers, being able to kind of spitball different ideas, and more importantly, see what cool, visions you have in your mind. I'm always the first person to say, dang, that looks like way better than what I thought. If I would have designed it, it wouldn't have looked nearly as cool as that. So I think that's just so fun and so neat. And it's neat seeing what people think whenever it obviously comes to fruition, for sure.
Yeah. Back when I used to do more design than software stuff, I was always walking around looking at how everybody did everything else out in all different kinds of things, like houses and buildings and cars and trucks. And like a lot of times designs that we were working on was a completely different industry, but I'm like, you know what? That's pretty slick. I wonder if we can incorporate those things. To me, that was always the fun piece of it. But we talked about this a little bit at the beginning, and I think this will be a pretty good question to sort of sum up the end of the show. and you took a non-traditional path to get to doing really cool, amazing things. So what advice would you give to someone starting in engineering or manufacturing?
Yeah, awesome questions, because it's one of those, it's tough because I am college educated. I'm highly college educated, but I don't have an engineering background. And so what makes that tricky is that it makes it to where, just because you want to, design parts doesn't mean that you have to take a traditional route. The coolest thing now is University YouTube. That's what I call it. You can find so many awesome tutorials on how to do certain things through YouTube. And then also, I spend most of my time on Instagram. Well, I spend too much time on Instagram, but most of my social media focuses on Instagram. And there's so many remarkably talented CAD designers over there that, you can ask questions to. And most of them are so receptive to helping. I think the one thing that I'd recommend, and I try my best to answer as many questions as I can for people, is try and figure it out on your own. Don't just ask a lazy question. Usually have a question with follow-ups of like, I tried XYZ and this didn't work. That's usually going to yield much better results than just being like, hey, how do you do this? Because as anybody who's designed in SolidWorks knows that to get from point A to point B is not linear at all. It's never, ever a straight line. And so I think that's probably the biggest thing. I think from a SolidWorks specific CAD design standpoint, there's actually an Instagram page that recently popped up in my feed, probably in the last 6 months. Actually, I think he commented on this a little bit ago. Wilkerson Customs, and the coolest CAD design stuff that I've seen, because it's just like none of it's practical, which shout out to that. I love it. And he does a really, really good job of doing time-lapse CAD design stuff. So he'll actually show conception reality, going through and modeling something. And what's really neat about that is that he makes it look way easier than it really is. And anybody who's started in SolidWorks, you kind of get that Dunning-Kruger effect, which is definitely the more you learn, the less you know type of scenario. But it's really neat seeing how he'll go through in time lapse, and then he does like a voiceover where he kind of shows how he's going through and doing it. Whereas most CAD designers, myself, I fall guilty of, is all screenshot, like the completed product. But I don't actually really show the design follow through, only because I've just never figured out how to do it efficiently, and I talk way too much as is. And yeah, so shout out to that's Kale. I know Kale. He used to run my Tube Laser. Don't listen to that guy. He's a real piece of crap. He's just trying to suck up for me. No, Kale. Really, really quick, I will say that Kale Tanner, the guy that just commented. What's so cool is that he came in and started working for me as an 18-year-old kid, well, maybe 19, fresh out of college. He was just a brand new welder fabricator, just wanted to do some welding stuff. I taught him how to run the Tube Laser, and he gravitated towards it really, really well. And once he learned that technique, then he wanted to try and get into more fabricating. Then he started getting design stuff. And even though he's a trader and he left leaving Overkill, he's doing his own thing. And it's so cool seeing him flourish. And it's so cool because he'll ask me a bunch of SolidWorks questions. And I always feel so confident when he asks me, because he's like a first grader and I'm like a fifth grader. And so I'm always going to know the answer to any question he asks. And but no, in total honesty, it's really cool when people feel confident and comfortable asking you questions, because again, I definitely get some serious imposter syndrome. I mean, obviously, chatting with you guys and being involved with SolidWorks is just it's incredibly humbling, because it's such an intimidating software, and literally every single time I turn the software on, I learn something new, or I learn a different keystroke, or I learn a more efficient way of doing something. And that almost drives you to want to use it more, because it is one of those that the more you use it, just you continually get so much better with it.
Well, I think it's a two-way street there, man. I'm pretty humbled to have you show us how you're doing things and all that too. So I think that it's two-way street there as far as perspective and what's going on. We do have one last question that we will ask, and then we'll wrap up. The question is, do you utilize PDM, and if so, do you give your guys floor access as a viewer?
No, we're not that big. I think if I had more cookies or more fingers in the pot, or however you word it, if I had more individuals involved in it, I definitely would. The good thing is that, from a primary fabrication standpoint, it's me and three other guys that are doing most of the primary fab work. And so because of that, it ends up being one of those that we don't necessarily have to do a PDM. If I had a bunch of people, or if it was getting outsourced, it was going, to different places, I totally would. And it makes a lot of sense to do that. But at this rate, it's enough that we use eDrawings. And eDrawings actually has a really neat app, not to shout out eDrawings, but they got a neat app on their phone. Well, I think you can download it on your computer as well. But on my phone, I can send guys a full assembly, and they can actually go through it. They can zoom it. They can pan and rotate. Because that's the only other thing with prints, is that it makes it really difficult because a print is still two-dimensional. So if they need to try and see how something goes together and they just wish they could rotate it just a little bit, being able to work in conjunction of having the prints as well as those 3D models via eDrawings on their phone is just like so convenient. It's so awesome.
Yeah.
So
yeah, eDrawings and being able to visualize 3D makes the world a better place compared to trying to have to visualize depth on a print with something you've never seen before, right? Like that's the difference too, is you guys are doing lots of one-off small unique things versus we're building 50,000 mini trucks next year, right?
Yeah.
So it's sort of everybody's on their different journey, and you got to do what's right for you. Luckily, you have the tools to do those things.
Yeah.
So the one thing I will start with saying is I can't thank you enough for stopping by the booth and meeting us at SEMA. I do appreciate that. We had a great chat. The other thing is I really appreciate you jumping on here with us today. I know that you and myself and some of the other team here at SolidWorks are talking about different things maybe in the future that you'll work a little more closely with us on.
Yeah.
But with that said, when everyone after this show says, I want to go work for Joel and I want to be part of this cool new thing that we're doing at Overkill Racing and Chassis, how would they get a hold of you or follow you or, learn more about what you're doing? What's the best way to get a hold of you?
Dude, I love it. Asking the important questions. So Instagram is probably the best way to see the content that we're doing, which is just Overkill Racing and Chassis on Instagram. If you have questions or want to send your resume, info@overkillracingandchassis.com. I couldn't find a smaller URL than that. Is probably the best. And that's where we get all of our resumes brought into. We're always looking for more help, always looking for people that have a great aptitude to wanting to learn new stuff, to have a good work ethic, be punctual. You don't have to be this remarkable welder fabricator to come work for us. We like to actually have people that we can kind of mold and shape into, what we eventually see them to be, similar to obviously like a Kale example would be a really good example of that. So, I would say that those are probably the two best ways, is through Instagram and then through our email. Yeah, info@overkillracingandchassis.com.
Ian's on top of it. He
makes
the world work, you know, and to help Ian, we do have to pay the bills. So please like and subscribe to this. Please, keep part of our other live things that we do every month. Next month in December, we're going to continue the 30th celebration of SolidWorks, 30 years. And we're going to have John Paul Abbasi on with myself here in just a couple short weeks. So please stay open for that. And again, Joel, I can't thank you enough, man. You're welcome back anytime. And I'm going to continue to Instagram stalk you with all your design and builds, because as a fellow gearhead car guy, what you do is truly amazing. So thank you so much. So
I want to show my model real quick, because everyone always thinks that, just because, you're a designer, that you don't run into the ketchup and mustard. I think I had it right here. I don't know what in the heck's going on. I'll have to go back and look, but I don't want people to think that like, that we don't run into random issues running through your design. So I don't know. It could just be a simple rebuild error. It definitely wasn't like that, but yeah.
It always starts with control Q, my friend.
That's
where we always start.
I love it. So yeah, I just wanted to show that because I don't want people thinking that everything's perfect. It's all rainbows and daisies all the time. So I try to keep the potty words to a minimum, but there's definitely times that I'm like, what in the heck? This was just perfect, and now all of a sudden it's a pain in the butt. So
Ian always puts me on a 5-second delay when we do these because the shop guy slips out every once in a while. So he's got his finger on the mute button right now as we speak.
I love it.
Yeah.
So
cool. Well, thank you, everyone. Join us again next week. And Joel, I can't wait to chat after the episode here about some of the things we got going on together.
Yeah. Thank you so much. And again, truly humbled. SolidWorks is just, it's neat because it's such an awesome software to use. It's got a little bit of a learning curve, but like once you get the hang of it, it's really cool. But what's cool on my end that I'm now starting to see is it's such a rad company to work side by side with. And so that part is arguably cooler than the software alone, which I think the software is awesome to begin with. So yeah, that's it, dude. That's all I got. Yeah.
We feel the same, but thank you so much. We appreciate it. And we'll catch you all next week.
Rad. Thank you so much.
Next month.